Hi, I'm Priyanshu Lohar, and this video is part of the video series which is dedicated to data structures and algorithms. In this video, we will study what data structure and algorithms is, what is computational complexity analysis, and just the normal basic stuff. Data structure. So data structure is just an efficient way of organizing our data so that it facilitates easy retrieval and efficient memory allocation. So there can be various ways to store data. We have two examples right in front of us. The first one is stack. It works like this. We have a first data block which is 1. After that, on top of it we'll store 2. On top of it we'll store 3. On top of that we'll store 4. And on top of that we'll store 5. And the retrieval would be from the very top. From 5, then 4, then 3, then 2, then 1. So this is just like how we store books on top of each other and it forms a stack. The data retrieval would only be from one end, which would be from the top end. The other way of storing data would be in a queue where we can store data on from the back and we can retrieve data from the front. It would be like we can enter data from this portion and we can retrieve data from the beginning of it. An algorithm is a step-by-step process to solve a particular problem. All the steps in this process would be chronological in nature. Let's take a problem for example. We have an array and we need to find a value which is 6, if it is present in this array or not. So the algorithmic approach would be, we'll start with the first element, compare that first element with the target which is 6. It isn't equal, so we'll move on to the next element which is 8. It isn't equal, then we'll move on to the next element which is 15. Then we'll move on to the next element which is 6, and this element equals our target, therefore it matches it and our target has been found. So what we'll do now is we will return its index which is 3 because array starts from 0, then the next would be 1, next would be 2, and next index would be 3. Now in data structure, there is something called abstract data type. So abstract data type is an abstraction of a data structure. It only provides us with the interface with which data structure must adhere to. Let me give you an example. So list is a type of abstract data type. Its implementation is linked list dynamic array. Queue is an abstract data type and its implementation would be linked list based queue, array based queue, stack based queue, and the much simpler example would be vehicle. Vehicle is an abstract data type. It gives us the idea of how basic things should be like. There should be wheels, it should accelerate, it should stop, it should pause. And its implementation would be a golf cart, a bicycle, a motorbike, a sports car, and other kinds of vehicle. Next up, we have a computational complexity analysis. So the complexity analysis is a theoretical assessment which measures how an algorithm is using a computational resources. It gives us the quantitative understanding of the speed and the space requirements that an algorithm will need when being executed. The key concepts in complexity analysis are time complexity, space complexity, and big O notation. Time complexity means how much time does the algorithm takes. Space complexity means how much memory requirement does the algorithm has. And the time and space complexity both are function of the input size. Big O notation. Big O notation is a way to describe the upper bound of algorithm's time. So for example, a constant time would be big O of 1, logarithmic time would be big O of log of n, and so on and so forth. We will go towards the properties of big O. So big O has two properties. It only takes into consideration the variable which is reaching almost infinity in an expression. So therefore, for example, if we have this kind of expression, then the big O would consider only big O of n. If we have this kind of expression where the two variables are being multiplied, then only we will consider the big O of n because it is much bigger. To give you an example of what does it really mean, here we have an expression. Let me go there. In this expression, we have 7 log n cube plus 15n square plus 2n cube plus 8. In all these terms, the n cube is of the highest degree and thus it is dominating the complete equation. And therefore, the complexity analysis would give us big O of n cube as a determining factor in the algorithm's uses of time and memory. And since we are talking about time complexity analysis, so big O of n in this case would be big O of n cube. The different big O time complexities for different algorithms are like this. For binary search, it is big O of log n or logarithmic. If we are sorting using merge sort, then it would be n times log n. If we are finding subsets of a particular set, then it would be n squared. If we are finding all the permutations of a string, it would be n factorial. And if we are treating all the cells in a matrix of size n by m, it would be n times n. Yeah, so this is it for this video. Drop a comment or reach out to me on this email if you wish to interact with me more upon this topic or you have any suggestions. Thank you.